Yes, that's right, Fatorma. The elements that you add to put in, and this is the product, is what you make. Okay? So in the reactants, let's take a look at what are the elements in the reactants. Can you tell me what are the elements in the reactants? You have, okay, C, carbon, and you have oxygen, and then hydrogen. That's it, right? What about the products? Well, why would you not? Where would you get nitrogen from? Let's say nitrogen. Where, you can't, right? You can't expect to get something out of something that wasn't there in the first place, right? Okay, so let's count how many carbon do we have. Okay, so in this CO2, how many carbon do you have? C is right here. So you have 6 carbon here. 6 times 6 is 12. How many atoms altogether? 36 atoms altogether, right? Okay, so if you start with 36 atoms, how many atoms should you have? 36? Yeah, should be. You can't make more. What happens though if you have less? Could it happen that you start with 36 atoms and then you end up with 35? Can that happen? No. What do we call this? The law of conservation of mass. Yeah. So now let's take a look at carbon. How many carbon on this side? Count. You see here? 6. How many oxygen? You have 6 here plus 12. 6 plus 12, 18. And how many hydrogen? You got 12, and that's it. Well, what do we expect? If you started with 6 carbon, how many carbon should you have in the end? And so on and so forth. But they are rearranged. You see that? That is what a chemical reaction would be like. So for example, you have, I'm going to use Delmar and Emmanuel. Let's say they are, they're holding hands, they're buddies, they're holding hands, right? And then these 3 guys, Fatarma, Adam, and Ashinafi, they're also holding hands in a group, right? They're holding on to something. That's their chemical bond. And then what happens is they get rearranged. And now I say, Delmar, you're now going to team up with Fatarma, and then these 3 guys, or sometimes Emmanuel and Ashinafi. And then Adam is by himself. That could happen as well. You could have something plus something plus something. It doesn't have to be just something plus something, right? You see here, you only have 1 plus. You can have 3. It depends on the chemical reaction. So what happens is atoms are the same except will be rearranged. When they become rearranged, that's what we call chemical reaction. Yeah. So in a chemical reaction, you know how we started in this class by talking about chemical changes? Chemical changes is the result of a chemical reaction, which is just the rearrangement of all those atoms in the periodic table. Okay? What about pencil? Who's got a pencil? I've got a pencil right here. You see this pencil? Right? See that pencil? What do you think is this pencil made of? Look on the periodic table. And I'm talking about that little tip there. Actually, even the wood. That wood is made of mostly carbon, right? But with a bunch of other stuff. But when you burn something, it doesn't matter what you burn. Anything organic. Anything organic means it contains carbon, hydrogen, oxygen. When you burn something, what happens is the hydrogen evaporates. It becomes part of the air. The oxygen evaporates, becomes part of the air. What's left is carbon. Okay? That's what happens when I die and I have my body cremated. What's going to happen is my hydrogen that I used to have in my body with water will become part of the air. The oxygen that I used to breathe and also part of my body will become part of the air. Okay? And the only thing that's left would be carbon, and it's all the water has been taken out. Dihydrogen monoxide has been banned. And carbon is only thing that's left. So I will become just like the tip of that pencil. Okay? So that tip of that pencil may have come from our ancestors that have become part of the earth from many, many years ago. Could be dinosaurs, could be animals, plants, people. that have been in the ground for years and years. And the other parts of their body, just part of our universe. Isn't that amazing? We're all conserved. We don't leave even after we die. We just don't see them, just at like a different dimension. Now what happens, you see that carbon, right? It's pure carbon. It's like combination of C, 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 C. It's a bunch of C, bunch of carbon atoms put together, right? What happens now if I compress it? And Earth does this all the time. If you squeeze all this carbon, that charcoal right there, if you squeeze it, you know what happens? It's still carbon, because you can make something out of carbon, right? But they look different, and they could form like that. What's the difference between this and that? You see, these are exactly the same thing. They're carbon, that's all it is. You could call it graphite, you call it diamond, it's the same thing. It's just carbon. Your body is made up of diamonds if you get squeezed. Okay, so just rearrange, that's all that happens in a chemical reaction. Okay, so practice here, we did this already. On page 17, how many carbon atoms in the reactant? We did that, so 6. How many carbon atoms in the product? Still 6. How many hydrogen? 12. How many in the products? 12. And how many oxygen? 18. And how many 18? Are any atoms destroyed or created during the reaction? No, never. Why? Because nature says it is conserved in a system. And the system is, what's our system? The universe. So nothing leaves the universe. Okay? Even if, here's Earth. Here's Earth. Okay? What happens when water from the ocean gets heated? It gets warm summer day. Yeah, it evaporates. So the water, it evaporates, right? Hot air is less dense. And then it's why does it stay in the clouds? Why don't clouds go out in the outer space? Yeah, that atmosphere made up of ozone mostly. It prevents. It's like a blanket protection. It protects us from what's out there, so it doesn't come in so much. It still comes in, and it prevents the water and everything that is on Earth to leave. So everything is conserved as well. All the water that is on Earth, every water that's on Earth from 4.5 billion years ago, is the exact same amount of water. Because you know what? You go, well, Blaine right here, Blaine was born this small, right? Tiny, right? You actually started as a tiny little seed. That's an atom from your parents, okay? What happens is now you grow, and then you've got all this mass. Where did that come from? From the food that you eat, from the water that you drank. So when you die, it's just gonna go back. You didn't make it. You did not make all this mass. It came from the stuff that you ate. You gotta consume the food that came from Earth, and you return it when you're gone. Law of conservation of mass and energy. Okay? Amazing. Also, if you burn something, you may not exactly get all of the mass, because some of that mass has been converted to pure energy in the form of heat, in the form of light. So yes, if you burn this book, right, and you weigh it to be, let's say, 50 grams, when you burn it, the ashes will not be 50 grams. That's why you can put a person's body in a small urn, because all the other stuff has been converted to pure energy, and they're just like everywhere now. It's kind of comforting to know that too, that people that, you know, are gone, the energy is still there. Okay, we're done here. Yeah.
Like here in the program we have G and S. What does represent it?
Which question, Adam? Oh, right here. The arrow.
In the parentheses we have G and S in the equation, like CO2.
Yeah, this one here. C6H12O6 6O2.
The G.
Yeah, OC. Okay. Thank you. I'm glad you asked that. Okay, so what this basically is a designation. I was gonna actually talk about that next. That's good. The words that are called the subscripts, right? So you have subscripts that are numbers, but you also have those subscripts in terms of letters, right? So the S means it's solid, and L is liquid, That means it just melted. And G is gas. And you don't have it here, not in this equation, but AQ means aqueous. Now you go, what in the world is the difference between aqueous and liquid? Aqueous, that means it's dissolved in water that you guys wanted to ban. You're gonna hear the whole, yeah. Yes, I know you wanted to keep it, Doug. That's right. You're part of the group. We are in this together. So aqueous means, let's say you take sodium chloride, you put it in water, you stir it, now it's dissolved, right? That's not called melting. You won't call it NaCl liquid because it is actually mixed in with water. It's dissolved, meaning it has a chemical reaction and it broke up. Okay? So that's the difference between aqueous and liquid. Liquid would be if I melted water, for example. You started with H2OS. What would be an H2O? Ice. An H2OL? Water. They're all water. But H2OL, yeah, we just call for some reason the liquid water. Water. But they're all water, right? Just ice and gas is steam. Yeah. They just come in different name, but it's all DHMO. Okay. What else was there? Okay, so there will be more coming on that later on when we write chemical reactions. Okay, so can we just do this one again? We've done enough counting atoms already, so I'm just gonna go over this quickly. How many hydrogen? 4. How many oxygen? 2. Okay, let's see how fast we can do this. Quick, it's a race. Magnesium? 3. How many O? 6. How many H? 6. Whoa. Okay, you need to review that. Why? Hang on, let's go over. Why is oxygen 6? You see this 2? That is part of every single thing in the bracket. That means 2 times 3. Okay, same thing with hydrogen. You see hydrogen's inside the bracket? So it's part of the 2. So 2 times 3. Okay, last one. Let's do this fast. How many N? 4. See? 2 times 2. How many H? 8 times 2. 16. And how many S? Only 2. All right. Okay? So we can do the balancing equation now. We're ready. Now, before you can do the balancing chemical equation, which is something you'll be doing all the way to whatever level of chemistry you're going to be doing, we have to balance chemical equation. It's a very important skill. Okay? Because chemicals actually do not form unless it's balanced. Like in reality, the reason why reactants form a product is because it's balanced already in nature. So we need to make sure that everything is conserved. Okay, so let's take a look at this one. So now, here's a very simple balancing chemical reaction now. So what we need to do, here's the strategy. I'm going to write down the strategy here. Strategy. Strategy would be your trick of the trade. So when you're balancing chemical equation, the strategy is to list the number of reactants and the number of products, and then go from there. So start by putting your reactants and products, and then figure out, and then add the coefficient as you need. Okay? Now, the coefficients are the only things that we can add. Never change the subscript. We cannot change the subscript because the subscript tells you the characteristic of the element, of the chemicals, okay? All right, so let's take a look here. So what I'll do then is, again, so I usually put a line right there. You see the arrow? That is before and after. Reactants and products. That's the separation. So I'm going to put H and O. That's the reactants. And then I'm going to list H and O. And I like to list them in that same order so that you can compare it side by side. Okay? Because you can't compare apples and oranges. It's like, what's better? Which one is better? Ashinafi or Emmanuel? Well, you can't compare that because they're best on their own, right? Because you're only yourself. You're only gonna live your. So oxygen is oxygen, hydrogen, oxygen. You can only compare the oxygen with the other oxygen. So list them in that order. That makes sense? All right. So how many hydrogen in the first? 2. How many oxygen? 2. Okay. What about hydrogen on the right? And oxygen? Okay. That's what I mean by listing them right away. And then we have a problem. The law of conservation of mass is not followed. We gotta make sure we follow it. So oxygen is an issue here. We need to make this one 2. You can't subtract this because it's already there. You can't take it away. But you can add the coefficient here. So I can't put 2 as a subscript. You see this? Never change the subscript. That's the rule. You can only add coefficients. So how do I make 1, 2? Put the 2 right there. So now let's take a look at hydrogen. How many hydrogen?
4.
Now you have 4. So I cross it out and put the new one. And then oxygen. Now you have 2. Now we go back here and we have a problem. So oxygen, we're good. So I check that. Hydrogen, we need to make it 4. Put the 2 right there. So 2 times 2 is 4. Now check. Hydrogen, 4, 4. Oxygen, 2, 2. Done. So this is what happens when water is synthesized in nature. You actually get 2 molecules of hydrogen gas, okay, which is explosive, and 2 and only 1 of hydrogen. So the proportion is, here's hydrogen, so you need, there's H, and O is only this much. That's why it's called H2, and then O, the ratio of hydrogen and oxygen is 2 to 1. Does that make sense?
Yeah, 4.
You can actually, can you go the other way around and make water break up into hydrogen and oxygen? You can. How do we do that? Electricity, high energy. You can force any reaction backwards.
Is that called hydrolysis?
Hydrolysis is the reaction that you call it when you put a lot of electricity here. You can make water go backwards and form hydrogen gas and oxygen gas. And you could make that explode and burst in flame. You can make an atomic bomb out of water. And in a nuclear power plant, the product, when it mixes with the oxygen in the air, is water. That's why nuclear power plant is clean, because the waste is water. Unless it leaks, and then there goes the whole town. Okay, so that is the key to balancing chemical reaction. Just remember the foundation, the strategy is, here's the strategy, the trick is to list the reactants and the products, okay, side by side comparison, and then add the coefficient as needed. That's it. You got all these. You see this? That's, the book tells you these are the rules. Summarize it in that.
Yeah, I find
Makes sense, right?
I find when I read the book, it seems overcomplicated and they say things backwards.
Yeah, that makes going to class and having a teacher so much easier than reading a book by yourself. Yeah. So we're good to go and do this example. Okay, so this is what's happening. This is called methane. And methane, and don't worry about that, you will learn how to name. Oh, can you guys name this one CH4? I know you can. What kind of bonding is CH4? Is that ionic or covalent? Covalent, how do you know?
Hydrogen.
Hydrogen, that's right. Whenever you see hydrogen and carbon, oh, it's both of them. Both of them, it's a double whammy. It's covalent. So how would we name this? Who wants to name it? Okay, Ashinafi says?
Carbon tetrahydride.
Exactly, excellent. Carbon tetrahydride. Carbon tetrahydride, aka also known as methane. And methane comes from the waste gas, aka farts, of cows and herbivores. So the animals that eat all grass and plants, when they release their gas, because they have like multiple stomach, right? So yeah, that's methane, mixes with oxygen, and this is what they make. So think about that. Cow fart mixes with oxygen in the air and makes carbon dioxide and water. Hey, we do that too, right? We do that too. Okay, so let's do this. Reactant is on the left hand side. What do we have? Okay, can you try this on your own? Go. Go on your own. You got 10 seconds. Come on, 10 seconds.
I can't even, I have to move my glasses.
You lost 10 seconds, now you got 5. Mhm.
Can you add a one coefficient? Just one?
You can add, yeah. If it's 1, you don't even have to include it. The number 1 is invisible in chemistry.
Oxygen balance.
Okay, so let's take a look. It is good to work with a pencil when you're balancing chemical equations. Work with a pencil, okay? So you can always erase it. It is a trial and error when you're balancing. So let's see what you have. So for every 1 methane, you need 2 molecules of oxygen, and you make 1 carbon dioxide and 2 molecules of water. Is that what you got? Okay, let's take a look at before. Before we added anything, did we get this one? 1 carbon, 4 hydrogen, and 2 oxygen. We're okay with counting? Same thing with after, 1 carbon and only 2 hydrogen and 3 oxygen, right? So that was okay before. So what you need to do then first is, all right, I have a problem with hydrogen here, so I've got 2. I need to make it 4. So the only way you could do that is add the 2 in front of it to make it 4. 2 times 2, now it's 4. But when you change the hydrogen, it also changed the oxygen. So now you have 2 oxygen on this side in H2O, but you still have the 2 oxygen there. Now it's 4. Okay? And now you go back to the reactants and you go, well, oxygen only had 2. I have to make it 4. The only way is to put the 2 there. So you keep going back between reactants and products until they're the same.
Which side would you recommend starting?
You start with the one that is, it doesn't matter. You actually leave the simplest one till the end. So I would leave the oxygen. Okay, that's another strategy. Good question. Leave the simplest molecules in the end. Why? Because that is the one that you can manipulate easier. Because when you manipulate, let's say just O2, that's the simplest molecule here, you don't change the other ones. Okay, so I save the oxygen till the end. And again, it's trial and error. Okay?
4 oxygen.
4 here.
How would you get 4 again?
4 on, I added the 2 coefficient here, so 2 times 2. Now it's 4. Okay? That makes sense? Okay? So you can't cancel. So you just, well, you're okay with counting in the beginning. So once you do that, you go, what's different? So I noticed that H is different. So 4 and 2 right there. So I had to change the smaller one. You can only increase it. You cannot reduce it. So you already have 4 hydrogen here. You can't reduce that, but you can add hydrogen. That makes sense? Okay. Let's try the second example down here. So here's what I'll do again. Draw a line right underneath the arrow. Okay, let's write down the elements of each one. So H, Cl, Mg, and Br. You notice that I'm writing the elements. I'm not writing any numbers here. So even though this one is Br2, I leave it as Br, and then I just look at what do they have Okay, hydrogen, how many on the left? One. How many chlorine? Only one. How many Mg? One. And Br? Two. Okay. Now I'm gonna rewrite this here, HCl, Mg, Br, in the exact same order, even if they're not in that order. Okay, so H, 1, Cl, 2, Mg, 1, and Br, only 1. So we have a problem with chlorine and magnesium, actually everything except hydrogen. Okay, so let's take a look at this one here. And in terms of simplicity, they're all exactly 2 elements per compound. So it doesn't matter what you do first. So I'm gonna just randomly choose chlorine. I've got 1 here. I have to make it 2 because it has 2 on the right side. So what do I put? Right here, I put 2. Now look, when I change chlorine and made it 2, make sure you're showing that you're crossing it out. Otherwise, it's gonna look like it's 12. And then hydrogen becomes 2. So it's so far so good. Now on the right side, hydrogen is 2 on the left. I gonna make this one 2. So put 2 right here. This now becomes 2. Are you guys okay following? Hang on.
Like you're adding 2, like
I add 2 because I need to make it 2. Because you see it started here with chlorine had 2. Cl2 is 2 chlorine. So I need to make the left chlorine 2.
oh yeah.
That's why you add the 2. If that was 3, then you'll have to add 3. Okay, so look at what happened to bromine when we changed hydrogen. It became 2. Okay, now, is that good? 2, 2, 1, 2. 2, 2, 1, 2, done. So this is the final.
What would you call that?
That's just balancing it by trial and error. It's called balancing by inspection, actually. Yeah. There is another way to balance chemical equation. It's called by oxidation and then by acid and base reaction. You will tackle that in chemistry 40S. And this is the easiest way, by inspection. By counting atoms.
Can you do another one?
Yeah, you bet. As a matter of fact, your homework is to finish the whole section. Practice. So you see that? Okay? And there's a lot of questions here, and it looks long, but it actually is just laid out to you in a chart. It just looks long. It's not that much. So by tomorrow, I would like you to do all the way to page 23. Use a pencil, please. So for your homework, do pages 21 to 23. Use a pencil. Otherwise, again, we're using a trial and error because you will keep erasing the coefficient as you add. So use a pencil.
So this is due tomorrow?
Yes, if you can, do as much as you can. I'm not gonna check your work. Can I show you a trick when you get to this part right here and everything is written out that way? So what I would do is you take a piece of paper and you're gonna just put it underneath there. I'll show you how I'll do this. Okay, so I'm using a pencil. I go H I have 2, Cl I have 2, and H here I got 1, and Cl I've got 1. So then I change this by putting 2 here, and that will make it 2. Done. Now you see I'm done there. So what I'll do then is now I still need to use my piece of paper to do number 2, but then this is now in the way. So look what I do. I will then fold this back this way, and I put it directly underneath. And again, look, O and O. I have 2, I have 3. So what I'll do then is I will change this to, I put 3 here, that will make it 6. And I will put 2 here, and that will make it 6. Look at this. I'm not wasting paper, and my brain is directly associated with the question above it. So again, I fold this, and I go to number 3. See that? You're not wasting paper. You see this? It's still, that's my number 1, that's my number 2, that's my number 3. But it's so much better than leaving it unfolded like that and working like this. See that? Work directly with it in close contact with the question that you're working on.
Can we do one?
Yeah, let's do this one here. So magnesium. So again, I go magnesium 1, oxygen 2. Magnesium 1, oxygen 1. So I'm gonna make this oxygen 2. So I put the 2 here, and that will make oxygen 2. But I also made magnesium 2. Now I gotta put 2 right here, and that makes magnesium 2. 2 and 2, done. And then so I go, look at this, my piece of paper. I fold it, go on to the next. It's a technique. It's just a nice technique. And with technique, you get to do more efficient work. You gotta work more efficiently, not harder. Okay? Work smarter, not harder. I'll see you tomorrow. So, you have no school on Friday. Tomorrow's Wednesday, right? So, yeah. Got 2 days with you guys. And then I won't see you for a while.